What if AI could understand human motion without an encoder, fit 3D bodies from messy multimodal inputs with millimeter precision, and even rethink how we search across images and videos from a composed text query? In today's episode, we dive into 3 striking papers that push AI toward more interpretable motion understanding, more robust 3D human modeling, and more powerful zero-shot visual retrieval. From biomechanical language to dense landmarks to reranking at scale, these ideas show how fast the field is evolving. Let's explore the first paper, Encoder-Free Human Motion Understanding via Structured Motion Descriptions. Encoder-free human motion understanding via structured motion descriptions replaces the dominant motion encoder to LLM alignment pipeline with a deterministic text translation of skeletal motion. The proposed structured motion description, SMD, maps 22 SMPL joints into 26 biomechanically grounded angle series plus absolute pelvis trajectory, then compresses them into hierarchical, natural language segments such as left hip flexion, increases 3 degrees, 81 degrees. This removes learned motion encoders, VQVAE tokens, projection layers, and multi-stage alignment. The only trainable component is LoRa on a frozen LLM with about 40 M parameters and 220 GPU hours on a single H200. SMD is LLM agnostic. The same text input works across 8 backbones from 6 model families, including Qwen 2, 5, Qwen 3, Gemma 3, LLMA3, 1, and GLM4. On BABL QA and Human QA, SMD reaches 66.7% and 90.1% accuracy, improving over IMORE by 6.6 and 14.9 points, and beating the controlled motion GPT-3 Qwen baseline by 16.6 and 68.1 points. On human ML3D captioning, it achieves R at 10,584, R at 20,794, R at 30,883, distance 2.35, and CIDR 53.16, outperforming Motion GPT-3. Qwen by 2.3R at 1 point and 31% CIDR relative gain, while also improving BERT score to 45.58. Ablations show that top 3 active joints often maximize QA, while all 2.6 benefits captioning, absolute trajectory outperforms egocentric encoding, zero-shot performance is non-trivial, with 35.6% and 31.7% QA accuracy, confirming that LLMs can parse the biomechanical text before task adaptation. The human-readable representation also enables interpretable attention tracing over specific joints and motion segments. Let's explore the second paper, OmniFit Multi-Modal 3D Body Fitting via Scale-Agnostic Dense Landmark Prediction. OmniFit is a 3D, native, learning-based SMPL-X fitting framework that unifies point clouds, optional front-view RGB, partial depth-derived geometry, and scale-distorted AI-generated assets under a single scale-agnostic pipeline. Its core novelty is a conditional perceiver-style transformer decoder built on point BERT features that directly regresses 600 dense SMPL-X landmarks, with an explicit spatial allocation of 120 head, 300 body, and 180 hand landmarks. This replaces dense correspondence aggregation used by Etch and yields finer supervision for extremities. A plug-and-play image adapter injects DNOV2 visual features without changing the base model, while a separate scale predictor estimates a canonicalizing scale factor from normalized point clouds to resolve unit box ambiguity common in generative 3D humans. At inference, SMPL-X parameters are optimized against predicted landmarks rather than regress directly. On CAPE and 4D dress, OmniFit reaches millimeter-level accuracy and beats the previous best ETCH by 57.1%, 75.5% in V2V, and 67.1%, 80.9% in MPJPE, respectively, establishing the first reported millimeter scale body fitting on these benchmarks. The image adapter further improves 4D dress performance from 0.589, 0.662 centimeters to 0.539, 0.622 centimeters V2V, MPJPE, surpassing multi-view optimization baselines, easy mocap, and diff proxy, despite using only a single front view. Training on a unified dataset combining CAPE, 4D, dress, Bedlam 2, derived synthetic humans, and Motion X-driven SYN body increases out-of-distribution generalization on Thuman 2, 1, and custom humans. The scale predictor reduces error by 41.9% V2V and 39.5% MPJPE on scale normalized assets, and attention visualizations show that the decoder learns explicit head, body, hand correspondences. Let's explore the third paper, UniCVR, from alignment to re-ranking for unified zero-shot composed visual retrieval. UniCVR proposes the first unified zero-shot framework for composed visual retrieval across composed image retrieval, multi-turn composed image retrieval, and composed video retrieval, all without task-specific human-labeled triplets. Its core novelty is a two-stage design that separates compositional query understanding from gallery retrieval. In stage 1, Quinn 3VL32B is fine-tuned as a dense query embedder and aligned to a frozen P-Core-G gallery space through contrastive learning on a curated multi-source corpus of about 3 5M triplets drawn from LLAVA pretrain, fashion 200K, 5G MAQ, and filtered AnyEdit. The paper introduces cluster-based hard negative sampling via k-means to force harder in-batch contrastive supervision and uses realign to map text targets onto the image manifold for type 1 supervision. Stage 2 adds an MLLM-guided dual-level reranker. An assessor MLLM scores only a budgeted top K subset with adaptive early termination, then uses those relevant scores for both global query refinement via score-weighted centroid fusion of candidate embeddings and local score injection, improving ranking without scoring the full gallery. Across 5 benchmarks, Fashion IQ, CIRR, Circo, Multi-Turn Fashion IQ, and WebVid CoVR, UniCVR sets new state-of-the-art. Stage 2 raises Fashion IQ average R at 10, R at 50 from 42, 38 over 63, 85 to 46, 1 over 64, R at 32. CIRRR at 1 from 40.1 to 47.93, Circo map at 5 from 34.97 to 43.09, MT Fashion IQ average R at 5, R at 8 from 50, 99 over 57, 87 to 54, 64 over 60, 53, 6, D, 4, 4, and WebVid COVR average R at K from 83.7 to 85.81. The strongest gains appear on Circo, where re-ranking is especially effective for multiple plausible ground truths. That's a wrap on today's AI paper highlights. Thanks for watching.